Good morning, students. Before watching this video, please make sure that you have watched the lecture number 11 of definite integrals, in which I have explained the definite integral as a limit of a sum and the geometrical interpretation of a definite integrals. So, in the previous lecture, we have discussed integral a to b f of x dx is equals to limit h tends to 0 h into f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1 into h. F of a plus n minus 1 into h. So here limit h tends to 0, this is limit n tends to infinity, because if the number of rectangles are infinity, the width is almost tending to 0. So here h we already discussed it to be b minus a by n into f of a plus f of a plus h plus f of a plus 2h etc. plus f of a plus n minus 1 into h. Here the geometrical interpretation of this is x is equals to a and this is x is equals to b, where this has been divided into number of n rectangles. Therefore, this is a plus h, this is a plus h, a plus 2h, a plus 3h, etc. So, number of rectangles like this. So, etc. The last rectangle is, this is a plus n minus 1 into h. This is a plus nh. So, the last before one is, the penultimate one is a plus n minus 1 into h. This is how we have discussed it. And this I have divided into number of rectangles. So, this is equivalent to limit, as I have started from a to a plus n minus a plus nh. If I start from limit n tends to infinity, b minus a by n into, if I start with a f of a plus h, then etc. it goes up to f of, this is f of a plus 2h, etc. This is f of, the last one is f of a plus nh. Of course, this is also correct, but compare this with the textual formula. Therefore, in the textbook it has been given in this way. So, this is equals to limit n tends to infinity, limit n tends to infinity. So, b minus a by n. This since this is summation of the series, so we can write it as a sigma notation f of a plus rh, where r runs from 1 to, because this is 1h, this is nh, so 1 to n. So in this way we can write the integral a to b f of x dx. So if you see this, then actually this is the limit of a sum and this is the sigma. So actually we are going to establish a relation between the limit as a sum with the sigma notation, with the integral. So the following 5 things have to be bear in mind. If a is equals to 0 and b is equals to 1, the lower limit is 0 and the upper limit is b is 1, then integral 0 to 1 f of x dx is equals to limit n tends to infinity, limit n tends to infinity, b minus a by n, 1 minus 0 by n, this is 1 by n, sigma r runs from 1 to n into f of, this is a is 0, r is equals to, r value is, this is r, h is equals to b minus a by n, b is 1 minus 0 by n, so this is f of r by n. So integral 0 to 1 f of x dx is equals to limit n tends to infinity 1 by n, sigma r runs from 1 to n, f of r by n. So if we see, then actually few things we can notice. What is that? Here the small change in the, because as limit n tends to infinity, 1 by n tends to 0, so it is almost approaching to 0, very small thing in the limit notation, which here can be dx. So 1 by n can be comparable with the dx. 1 by n is comparable with the dx. And see this r by n. So because this is function of x, here function of r by n. So r by n is nothing but x. And here this is first one, this is the second thing, and the third one is this is sigma limit n tends to infinity, limit n tends to infinity, sigma notation. This is nothing but the integral sum here. This is integral, and the lower limit and upper limit. So lower limit is equals to limit n tends to infinity, limit n tends to infinity, sigma f of r by n. So here if n tends to infinity, if 0, if we substitute here, 0 by n is 0. So 0 by n is 0. So therefore the lower limit is 0. And if the upper limit 1, if I substitute here, this is 1 by n. As in n tends to infinity, 1 by n tends to n by n, that is 1. So that is the upper limit. So these are the few things that you have to bear in mind while solving the summation of a series problems. So these are the few things that we have to notice. Integral a to b f of x dx is equals to limit n tends to infinity, b minus a by n, sigma r tends to 1 to n, f of a plus rh. This is the general term where r is varying from 1 to n. So here 1 by n. So if a is equals to 0 and b is equals to 1, then 1 by n is tending to 1 by n is converting into dx. R by n is converting into this here, because r by n is converting into x. Limit n tends to infinity, sigma is converted into the integral. Lower limit is limit n tends to infinity r by n, and limit n tends to infinity r by n. So this is how it will convert. Let us try to solve these problems. Evaluate the following limits. Limit n tends to infinity, square root of n plus 1, square root of n plus 2, square root of n plus n by n root n. This is equals to limit n tends to infinity. So this is root of n plus 1 by n plus square root of n plus 2 by n plus etc. plus square root of n plus n by n. This root I have brought inside this root by n. So this is equals to limit n tends to infinity. So here, since this is the summation of the series, therefore I can write the sigma notation. R runs from 1 to n square root of n plus. So this n by n is common, but here this is 1, this is 2, and etc. This is n. That means this is getting varied throughout the expression. Therefore, I will replace it as r into 1 by n. Now, this is equals to limit n tends to infinity, sigma r runs from 1 to n square root of. So, this is 1 plus, this is a plus b by c plus b by c. N by n is 1. This is r by n into 1 by n. Now, as we have discussed, so 1 by n is replaced with dx. Second, r by n is replaced with x. Thirdly, sigma limit n tends to infinity, sigma, this becomes integral, and limits are, my lower limit is equals to, this is r by n. So limit n tends to infinity, r by n. This is equals to, the limit is r equals to 1 if I substitute here, 1 by n. So limit n tends to infinity, 1 by n is equals to 0. N tends to infinity, 1 by n. This is equals to 0. So upper limit is equals to limit n tends to infinity, this same r by n, this time replace with the n. So n by n, this is 1. Therefore, the total given expression has become, see this here. So limit n tends to infinity, sigma 1 to n. So this is 1 plus r by n is equals to, r by n is replaced as x, 1 by n is dx, and limit n tends to infinity, sigma has become integration. This upper limit and lower limit is 0 and upper limit is 1. So this is, we know how to solve this problem. Integral root x is 2 by 3, x power 3 by 2. So 1 plus x whole power 3 by 2. Since the process is over, 0 to 1 is to be written here. So 2 by 3, 1 plus 1 whole power 3 by 2. 1 plus, in the place of x, upper limit, minus 1 plus 0. So that is 1 whole power 3 by 2. This is equals to 2 by 3. This is equals to 2 by 3. 1 plus 1 is 2. 2 power 3 by 2 minus 1 power something is 1. So 2 by 3 into 2 power 3 by 2 is 2 power 2 into 2 power 1 by 2. So 2 root 2 minus 1. So this is the answer. So now limit n tends to infinity, 1 by n plus 1 plus 1 by n plus 2 etc. 1 by 6n. Let us write in a standard form is, so 1 by n plus 1, 1 by n plus 2 etc. plus 6n can be written as 1 by n plus 5n, n plus 5n. So this is equals to limit n tends to infinity, sigma. So this is summation of the series. I can replace it with a sigma notation. So this is 1 by n plus So n, every term n is there, but here 1, 2, etc. 5n. So this term is getting varied. So I will write it as n. So n. This is r. I will write. Then this is sufficient now. So here n I replaced plus r runs from 1 to 5n. Okay. Now this is okay. Now limit n tends to infinity. What I have to try is I wanted to have r by n and 1 by n, for which what I am doing is sigma r runs from 1 to 5n. I will take n as n as a common. So 1 plus r by n. See, by writing this, yes, I can get r by n and 1 by n as well. So for this, the next step of this is limit n tends to infinity. Here, so the first step is r by n is to be replaced with x. Second, 1 by n is replaced with dx. Third one is limit n tends to infinity. Limit n tends to infinity sigma. So this becomes my integral, and upper limit, first lower limit is equals to limit n tends to infinity. Limit n tends to infinity r by n. So here 1 being the upper limit. So 1 by n. Limit n tends to infinity 1 by n is equals to 0. And in most of the cases, actually lower limit will be 0 only. And upper limit is limit n tends to infinity r by n. So r now is 5n by n. So n gets cancelled. So 5. Therefore, this has become limit n tends to infinity sigma, that is integral 1 to 5n has been replaced by 0 to 5, and 1 by 1 plus r by n is to be replaced with x into, this is 1 by n. 1 by n is to be replaced with dx. So this is equals to, we know integral 1 by 1 plus x dx is log mod x. Log modulus of 1 plus x. So this process is over. 0 to 5 is to be written here. So log 1 plus 5 is 6 minus lower limit log 1 plus 0, 1. So log 6, because log 1 value is 0. Limit n tends to infinity 1 by n tan pi by 4n, tan 2 pi by 4n, etc. tan n pi by 4n. So this is equals to solution. This is equals to limit n tends to infinity tan, this is pi by 4n, 2 pi by 4n, etc. tan n pi by 4n. For everything, pi by 4n is same. That means tan pi by 4n is same. Tan pi by 4n is same. So here this is 1 pi, this is 2 pi, etc. n pi. Since this is a plus, we can write it as sigma r runs from, this is 1 pi, so 1 to, this is n pi, n. So here n I will write here into 1 by n. So again I am telling you, this 1 by n is this, limit n to infinity same. Since this is a summation, therefore I have replaced it with the sigma. So the general term I have written it to be tan n pi by 4n, where r runs from 1 to n. First r equals to 1 you substitute in that. Pi by 4n. Sigma means plus. This time after r equals to 1, r equals to 2, you substitute tan 2 pi by 4n and you check it out, tallied, etc. This time the last term r is to be, this is r. So this time r is to be replaced with n pi by 4n. So now we've been discussing right from the beginning that we need to look for r by n. So r by n we are getting here. So 1 by n is also we get. So the next thing is r by n is to be replaced with x. Second, 1 by n is to be replaced with dx. Third one, limit n is to be replaced with integral, upper limit and lower limit. So lower limit is equals to limit n tends to infinity r by n. This is equals to r is 1. So limit n tends to infinity 1 by n is equals to 0. Upper limit is, as n tends to infinity, 1 by n tends to 0. So limit n tends to infinity r by n. So this time r value is this n by n, which is 1. So this is equals to limit n tends to infinity. Limit n tends to infinity. So this is limit n tends to infinity. Sigma is equals to integral. R runs from 1 to n, here 0 to 1. Lower limit is 0, upper limit is 1. Tan r by n is x. So this is r by n is x. So x into pi by 4. So pi x by 4 into 1 by n value is dx. So this is equals to integral tan x is log mod secant x. So log modulus of secant x value is here pi x by 4 by, see, integral tan x value I know, but integral tan pi x by 4 I don't know. So I have treated pi x by 4 whole to be x. Then it has become integral tan x log mod secant x by, so x quotient is pi by 4, with which I have to divide in. So from 0 to 1, this will become. So 1 by pi by 4 is 4 by pi. 4 by pi. Now, since the process of integration is over, substitute the limits. Log secant pi x by 4. So pi by 4. Pi into 1 by 4. So pi by 4. This is whole upper limit. Minus lower limit. Log secant x pi into 0 by 4. So this is 0. This is equals to 4 by pi. 4 by pi log secant 45. Cos 45 is 1 by root 2. Secant 45 is log root 2 minus log secant 0 is, secant 0 value is 1. Cos 0 is 1. Secant 0 is 1 by 1. So 1. So log 1. Log 1 value is 0. This is equals to 4 by pi log root 2. So 4 by pi log root 2 is 2 power 1 by 2. So 4 by pi. So this is log a to the power of m. M log a. This power will come forward. So 1 by 2 log 2. So this is equals to 2 by pi log 2. It's been giving the series. So with the help of that series, we need to find out the general term. So here it is directly given. So this is equals to limit solution, limit n tends to infinity, sigma I runs from 1 to n I cube by If I take n power 4 as a common, then this is 1 plus, this is 1 plus I power 4 by n power 4. If you multiply n power 4 into 1, n power 4, n power 4 into I power 4 by n power 4, this gets cancelled, I power 4 I left. So this is equals to, instead of r, here he has given I, that is the difference. Okay, here this is equals to limit n tends to infinity, sigma I runs from 1 to n. So this is I cube by, this is n cube, I cube by n cube into 1 plus I by n whole power 4 into, this is n power 4 n cube I have written, 1 by n I have extra. N power 4 is n cube into n, 1 by n is this, so this is n cube, so I power 4 by n power 4 is I by n whole power 4 I have written. Now, limit n tends to infinity, sigma I runs from 1 to n, this is I by n, this is I by n whole cube by 1 plus I by n whole power 4 into 1 by n. So here, very first, instead of r by n, here I by n I have. Okay, so I by n is to be replaced with the x. Second, 1 by n is to be replaced with the dx. Thirdly, limit n tends to infinity, sigma has become integration. Fourth, upper limit is equals to limit n tends to infinity, r by n. So upper limit is n, so n by n, so 1. This is the upper limit, and the lower limit is equals to limit n tends to infinity, r by n, not here, I by n. So here I by n, so replace with the lower limit, so 1 by n. Limit n tends to infinity, 1 by n is equals to 0. So everything we have, this is equals to limit n tends to infinity, sigma is integral symbol, I runs from 1 to n is 0 to 1, I by n value is x cube, because I by n is x, 1 plus, this is I by n is x power 4 into 1 by n value is dx. So we know how to do this process. So this is equals to integral 0 to 1, x power 4 derivative is 4x cube. Here x cube I have, 4 is missing, for which I will multiply and divide with the 4. So 4x cube by 1 plus x power 4 dx. So 1 by 4, this is 1 plus x power 4's derivative is 4x cube. This is f of x, it is f dash. Integral f dash x by f of x dx, log f of x. So log mod 1 plus x power 4 from 0 to 1. 1 by 4 log, substitute the upper limit. 1 plus x power 4 is 1 power 4. So 1 minus lower limit log 1 plus 0 power 4 is 1. 0 power 4 is 0. So 1 plus 0 is 1. So 1 by 4 log 2. N tends to infinity, sigma I runs from 1 to n, I by n square plus I square. So this is limit n tends to infinity, I runs from 1 to n, I by, take n square as a common, then 1 plus I square by n square. This is equals to limit n tends to infinity, sigma I runs from 1 to n. Here this is I by n by 1 plus I by n whole square. This is n square, but only n I have taken. So 1 by n I am left with here. So here, as usual, so I by n is to be replaced with the limit n tends to infinity, sigma is integration. So I by n is x by 1 plus x square into 1 by n is dx. Now the limits now. So limit n tends to infinity, r by n. So r value is 1, lower limit. So 1 by n, as limit n tends to infinity, 1 by n is equals to 0. Upper limit n by n. Upper limit is n is to be replaced with the r. So n by n is 1. So simply it has become x by 1 plus x square dx. So here 1 plus x square derivative is 2x, for which 1 by 2 into 2 I will do by 1 plus x square. So this is 0 to 1 dx. 1 by 2, 1 plus x square derivative is 2x. So this is f dash x by f of x log mod 1 plus x square. So the process of integration is over. 0 to 1 is to be written here. So 1 by 2 upper limit log 1 plus 1 square. So this is 2 minus log 1 plus 0 square. So 1. This is equals to 1 by 2. This log 1 value is 0. So 1 by 2 log 2. Further we can write it as log 2 to the power 1 by 2, because m log a is log a to the power of m. So 2 power 1 by 2 is log root 2. So the next question is limit n tends to infinity. This is given. So limit n tends to infinity. This is 1 power 4 also we can write. So 1 power 4, 2 power 4, 3 power 4, etc. n power 4. So power 4 is same everywhere. But here this term is getting varied. So 1, 2, 3, etc. So this can be replaced with r. This can be replaced with r by n power 5 into. So these are the plus symbols. Therefore, we can write it as a sigma notation. R runs from 1 to n. So you can even check it out also. So first give r equals to 1. So this is 1 power 4 by n power 5. So 1 power 4 by n power 5. So r equals to 1 is over 2. So 2 power 4 by n power 5, etc. This is n power, r value is n, the last term. So we are getting n power 4 by n power 5. This is equals to limit n tends to infinity, sigma r runs from 1 to n. This can be written as r power 4 by n power 4 into 1 by n. N power 4 into n is n power 5, because I want r by n and 1 by n combination. So this is equals to limit n tends to infinity, limit n tends to infinity, sigma r runs from 1 to n. This is r by n whole power 4 into 1 by n. Now, so limit n tends to infinity, sigma is integral symbol, and this r by n whole power 4 is x power 4, 1 by n is dx. So limit n tends to infinity, upper limit I am evaluating, limit n tends to infinity, r by n. So r value is n, n by n 1. So the upper limit is 1. Next, lower limit is limit n tends to infinity, r by n is same. In r by r place, so one lower limit is to be substituted. Limit n tends to infinity 1 by n, which is equals to 0. So this. So we have integral 0 to 1 x. So this integral x power 4 dx is x power 5 by 5. Process is over. Integration process 0 to 1 is to be written here. So 1 by 5 if I take apart from the process of integration. So x power 5. So 1 power 5 minus 0 power 5. So this is equals to 1 by 5. So the next question, limit n tends to infinity 1 plus 1 by n square, 1 plus 2 square by n square, etc. 1 plus n square by n square whole power 1 by n. Whenever powers are there, we will be usually taking the logarithm. So first and foremost, let us take the given expression with let L is equal to, I will take applying logarithms on both sides. Then log L is equals to log limit n tends to infinity 1 plus 1 by n square, limit n tends to infinity 1 plus 1 by n square, 1 plus 2 square by n square, etc. 1 plus n square by n square whole power 1 by n. So this can be written as limit n tends to infinity log 1 plus 1 by n square, 1 plus 2 square by n square, etc. 1 plus n square by n square whole power 1 by n. So log a to the power of m log a. So this power will come forward. So limit n tends to infinity 1 by n log 1 plus 1 by n square, 1 plus 2 square by n square, etc. 1 plus n square by n square. Now limit n tends to infinity 1 by n. So log AB, log A plus log B, it can be extended to any number of terms. So log, this is log 1 plus 1 by n square plus log 1 plus 2 square by n square plus etc. plus log 1 plus n square by n square. So this is equals to limit n tends to infinity. This is, since this is the summation of the series, we can write it as sigma notation. Sigma log 1 plus, this can be written as 1 square also. So in everything 1 plus 1 plus 1 plus is common. By n square is also common. By n square is also common. And this is 1 square, 2 square, etc. n square. This can be replaced as r square, where r is starting from 1 and ending with the n. So 1 to n. You can even, after writing this, you can even check it out. Into 1 by n is there here. So see this 1 plus, you give r equals to 1 and substitute in this 1 square by n square. After r equals to 1, substitute 2. Since sigma is the summation, plus 2 square by n square. So goes on this, r value is n now, n square by n square, this we get. Therefore this is equals to, now limit n tends to infinity, sigma is integral symbol, this is log 1 plus this r square by n square is r by n whole square, r by n is to be replaced with the x, so x square, 1 by n is dx. Now substitute the limits, upper limit, so limit n tends to infinity, r by n, so what is r here, r is 1, so 1 by n, limit n tends to infinity, 1 by n is equals to 0. Sorry, this is the lower limit. Upper limit is limit n tends to infinity, r by n, r value is n, n by n, so which is 1. So this we need to do. Now see this. This is integral 0 to 1 log 1 plus x square dx. This is not a normal thing to do. So this is a separate special function. So another function is to be treated as 1. So 0 to 1 log 1 plus x square into unity. So this is the first function and this is the second function. So first function into integral of second function dx from 0 to 1 minus integral of 0 to 1 d by dx of first function log 1 plus x square into integral 1 dx whole dx. So this we know how to, this by parts I have used, f of x into integral of g of x dx minus integral of d by dx of f of x into integral of g of x dx whole dx. Log 1 plus x square integral 1 dx is x from 0 to 1 minus 0 to 1 d by dx of log 1 plus x square. Let us suppose this to be x. Log x derivative is 1 by x. So 1 by 1 plus x square into, since this has treated to be x, we need to differentiate it later. So 1 0 derivative, x square derivative is 2x into integral 1 dx is x. Integral 1 dx is x whole dx. This is equals to x log 1 plus x square. So from 0 to 1 minus 0 to 1. This 2 I separated. So x into x, x square by 1 plus x square dx. This is the improper fraction because degree of f of x is 2 and degree of g of x is also 2. So degree or equals to degree of g of x, such kind of fractions are said to be improper fractions, for which we need to divide x square with the help of 1 plus x square. Otherwise you can even go for balancing. So 1 I will add and I will subtract also without loss of generality. So now x log 1 plus x square from 0 to 1 minus 2 a minus b by c, a by c. So 1 plus x square gets cancelled. Integral 1 dx is x. Integral 1 dx is x minus 1 by 1 plus x square integral. Integral 1 by 1 plus x square is tan inverse x. So the process is over. Now 0 to 1 is to be written here. This is equals to, now substitute the upper limit. 1 into log 1 plus 1 square. This is 2. 1 plus 1 square. So 2 minus lower limit 0 into something. This is 0. This we have found. Minus 2 in the place of x upper limit 1. Minus in the place of x lower limit 0. Minus tan inverse in the place of x upper limit 1, tan inverse 1, minus tan inverse. In the place of x, lower limit is 0. This is equals to 1 into log 2 is log 2 minus, this is 2. 1 minus 0 is 1. 2 ones are 2. Minus into minus plus 2. Tan inverse 1 is pi by 4. Again, 1 minus 0 is 1. Minus 2 into 1 minus 2. Minus into minus plus 2 into tan inverse 1 is pi by 4. This is 2 times. This is log L. So L is equals to log, if I shift to that side, e power log 2 minus 2 plus pi by 2. This is equals to e power log 2 into e power pi by 2 minus 2. This is equals to e power log 2 is 2 into e power pi minus 2 to the 4 by 2. Therefore, L is equals to 2 into e power pi minus 4 by 2. N tends to infinity, n factorial whole power 1 by n by n. Again, this is a power. Whenever power is there, we need to take a logarithm into consideration. So, first of all, solution is limit n tends to infinity, n factorial is 1 into 2 into 3 etc. n whole power 1 by n by n. So, since this is the power, I will take let L is equals to apply logarithm on both sides. Then log L is equals to limit n tends to infinity log 1 into 2 into 3 etc. n whole power 1 by n by n. This is equals to limit n tends to infinity. This is log a to the power of m log a. So 1 by n log 1 into 2 into 3 etc. n by n. This is equals to limit n tends to infinity 1 by n log AB, log A plus log B. So log ABC, log A plus log B plus log C. Likewise, this is log 1 plus log 2 plus log 3 plus etc. plus log n by, this is n. So this is 1 by n, 2 by n, 3 by n, etc. n by n. This is equals to limit n tends to infinity log, since this is the sigma notation, summation of series, I will replace it with the sigma notation. R runs from 1 to n. R runs from 1 to n log. So, in everything by n is common, but here where is in the numerator. So, R I will take. So, this is limit n tends to infinity, sigma is taken as integral, and this 1 by n is this. So log R by n is to be replaced as x, 1 by n is dx, and so limit n tends to infinity r by n. So lower limit is 1 if I substitute here. Limit n tends to infinity, 1 by n tends to 0. So this is 0. And limit n tends to infinity, upper limit is to be replaced with n. N by n is 1. So this is 1. So integral log x dx. We know how, direct formula for integral log x dx. X log x minus x. Otherwise, the second function is to be taken as 1 unity. So then it is f of x into g of x, product of two functions. So in the similar way, if you proceed, then we will be getting log L is equals to, this is x log x minus x from 0 to 1. This is 1 log 1 minus 0 log 0. This is over minus x is 1 minus 0. This is equals to log 1 minus 1 minus 0 is 1. Log L is equals to, so L is equals to log, if you shift to that side, e power log 1 minus 1. So this is e power log 1 minus 1. So this is equals to e power log 1 into, this is e power minus 1. This is equals to e power log, that means this is 1. E power minus 1 is 1 by e.
I believe you'll be somebody.